Yeah, Bharat, we are live now on YouTube. I think it's just about to start streaming in a minute. We will have maybe a minute of delay between us and YouTube and the Zoom on YouTube, basically. So,
Okay.
Yeah, it's live, Bharat.
Okay, it's live. Cool.
We can just see the things on the now.
I'm just logging into YouTube.
Yeah, that's. I've just shared the link. If somebody.
Okay, you've shared it in YouTube. Anaconda Navigator link, which I had attached.
All right, perfect. Let me do that.
I'll do it. I'm in YouTube. I'm just sharing it out.
All right. By the way, hi everyone who just have joined. We are just trying to ensure that all of you guys have the required softwares to start this class. So we have given you the instructions in the course itself to download these files. So kindly follow that. And also, if you guys have just joined now, we would just drop you the link to download the files. Okay, so guys, if you have just joined in, that's a link to download the Anaconda Navigator. So do install. We will be starting the session, let's say about at 5 exactly.
Oh yeah, so I've shared the link in YouTube. Yeah, hello everyone. So I believe you have installed Anaconda Navigator. So if you have not installed Anaconda Navigator, just go to this particular link. So it is attached in the chat box. So if you are in YouTube, it is attached in the live chat of YouTube. So you can just open up this particular link and download the software. So with respect to the OS that is present in your system. Okay, so just install this, and then after we could go ahead further in terms of the programming part of it and all in the further part. Like in the further session. So if you're done with installing Anaconda Navigator, just type in yes in the chat box.
Right, Bharat. So I think I just kind of put across another email to everyone just to ensure that everybody is possibly joining. I think there may be some participants who will be joining on YouTube too.
Okay, that's good, Suraj. Are we good to start the session? It's fine.
Yeah, perfectly. Let's begin, Advil. If you have the first slide of the presentation, so kindly pop it up, and let's just begin the introduction. Without killing much time, let's begin the classes. All right. So, by the way, hey everyone, very good evening to all of you. So, welcome to this course on computer vision for autonomous vehicles and ADAS. The subject is relevant to the part of, I would say, lane detection. All right. So in this course, we will try to touch base a bit more about the overview of computer vision, and also where we will be able to do some hands-on projects um, along with Bharat, who will be helping you to build the whole module for you. So this won't be a session where you just master computer vision, but this would be a session where you would be able to lay the foundation and understand how computer vision is actually used or can be used for the application in automotive, and what kind of stuffs come in between that if want to be the part of an activity in the areas of either self-driving cars or also on the ADAS applications perspective using computer vision. So Bharat, over to you to take guide the session. Thank you.
Yeah, thank you, Suraj. Okay, so the entire session is divided into is divided into computer vision and then Python, and also we'll be looking at the lane detection algorithm, so which we have developed in order for detecting the lanes. Okay, so first of all, we would start with basics of Python, and then we'll look at how we could use Python for computer vision. So then after we'll look at lane detection. Okay, so if you look at if you look at a self-driving car, so the self-driving car's objective is to understand the environment, and then based upon the environment, it needs to make certain decisions in order to move around in the environment. So for this, it would need to understand if there is a vehicle, if there is a lane that is present in the environment, or maybe it needs to understand what is the position of the vehicle and all. So for all these kinds of applications, we use self-driving. So we use computer vision, and also we also use machine learning algorithms. So our focus would be more in terms of computer vision. So let's look at how is computer vision used. So if you see here, so this is one of the example wherein the vehicle is trying to understand the environment. So you can see here the boxes which represents the vehicles that are present. Okay, so this is by using computer vision and machine learning. So where there's a vehicle and all. So similarly, there is also another application. So such as if you look at Waymo and all. So they use computer vision for detection. And if you look at the sensors which are present, so we have a camera, and then there is another camera and the LiDAR, and then we have a vision, the camera over here and over here and over here. So there's basically a camera at the top, over here and over here and over here. So these three cameras would be helpful in terms of understanding the environment that is present at the front of the vehicle. Similarly, at the rear, there is another camera. So wherein if in terms of if there's a vehicle in the rear of the vehicle, if suppose there's a vehicle over here, so it needs to understand that there's a vehicle, right? So in those kinds of scenarios, we would again use a camera. Okay. So, and also there's other sensors such as LiDAR and radar and all, but we're not going to focus on those because that does not come under computer vision. Okay. So only these are the sensors majorly which we would be using. So which would be helpful in terms of lane detection.
Hey, Bharat, your voice is down. Just check the audio.
Okay, just a second. I'll just check it out. How about now, Suraj? Hello.
Okay, I think
I guess Suraj, there's a internet connectivity issue at your side.
Sorry, it would matter.
So yeah, so computer vision is used in terms of lane detection. Just a second, looks like. Yeah. Okay, I'll write it. Lane detection, and it's also used in vehicle detection. Vehicle detection, and also in terms of traffic sign detection and for visual odometry. Okay. Odometry is basically the location of the vehicle where it is present. And also it's used in terms of mapping and all. Okay. So, these are few of the applications. So in terms of like understanding the environment. So we'll focus first with Python, because like Python is the major basic fundamental program which we would be using in terms of programming the algorithms to detect vehicles or to detect the lanes and all. Okay, so we'll start off with basics of Python. So I'll just open up a presentation which gives you a basic understanding on what is Python and how is it, like where is it used in terms of application point of view. Okay, so Python is one of the programming language. It is a high level programming language. So wherein Python could be used for many applications. Okay, so for multiplication, like in some sort of simple applications, if you look at multiplication, division, or matrix multiplication, and many more applications, like in simple terms. And also it could be used in many more advanced also application point of view. So such as in terms of image processing or developing machine learning algorithms or artificial intelligence algorithms and all. So we would start with few of the basics. So we're not going to dig in much more deeper in terms of Python, but only few basics, such as we'll look at how we could define a variable, or maybe how we could define a matrix, and also how we could maybe plot an output. Okay, so we look at few of the basics, and these are like few of the applications so that I have listed down. So you can see here, Python is used in machine learning, data analysis, image processing. So okay, so image processing, and also in AI, automation, OpenCV. So you can see, like in terms of OpenCV is basically one particular package which is used for computer vision. Okay, so then also there is other applications. So as you can see over here, and Python is like one of the most widely used in terms of 2020 report. So you can see with respect to other languages such as MATLAB, Swift, R, Java, Python. No. Okay, so the number of users are increasing. So the main reason is because like Python could be used in wide applications, and also it is much more easier. And also there is a lot of packages. Okay, so wherein like if you want to perform computer vision algorithms, or if you want to use machine learning algorithm, or develop an artificial algorithm, or in terms of automation, or also robotics, or any kind of like applications. So Python could be used for all these applications for a single, like a single language could be used for all these applications. Okay, so that's the main advantage of using Python. Okay, so then these are like few of the companies. So if you look at in terms of Python, where it is used, so it is used in like Google or YouTube or NASA, and also by IBM and many other companies. Okay, so let's start off with the basics. Okay, so let's say Python, how we could use, like very, very basic. So like how to write a Python code. So I'll just open up Anaconda Navigator. So if you just go to your, let's say Windows startup menu. So I'm using Windows 10. So you'll find Anaconda Navigator over here. So you can just click on this. Okay. So that is Anaconda Navigator. So which would launch this particular window. Okay. So here we have another, we'll say, sections. So here we will be focusing on Jupyter Notebook. Okay. So just click on launch. Okay. So when you click on launch, it will open up this particular section. So I'll show it you once more. So just go to Windows, go to Anaconda Navigator. So Anaconda 3. So there you'll be able to find Anaconda Navigator. Just open that up. So if you just click on it, it will open up Anaconda Navigator like this. So here, just click on launch. That is Jupyter Notebook. I'll just mark it out like this. So Jupyter Notebook. So when you click on launch Jupyter Notebook, so that will launch up this particular section. Okay, so I believe everyone have launched Anaconda Navigator. Just type in yes. if you have launched Anaconda Navigator and Jupyter Notebook, so that we could further go ahead quickly in terms of understanding how we could program, understand Python programming. Okay, so looks good. So now probably you would see here like this. So probably in your screen, you would see something like this in your screen. So these kinds of files, similar, not exactly the same. You would see like there's like Anaconda Navigator, desktop, documents and all. So just, this is basically the files that are present in your system. Okay. So just click on desktop. Okay. And here you can just create any folder. So I'll just show it to you. So just open up your desktop and create a new folder. So I've created a new folder, which is named ADAS lane detection. Okay. ADAS lane detection. So if you just open that up, and here in this Sparkler folder, paste this Sparkler image. So this image, you could find it in over here in the course. So that is over here in, okay, just a second. Computer vision for ADAS. We have the course, right? So you can just go to that and go to image data for computer vision and download the zip file. Okay. So the zip file, when you download it, so it's basically a zip file. So you can just download that. So extract the zip file over here. So it's basically one Sparkler image. So extract it over here. And we'll be using this Sparkler image for image processing and all. Okay. So we'll look into that in the further stage. But if you have downloaded the Sparkler image and I'll say extracted it over here, just type in yes. Okay, looks good. So then after, let's go ahead further. So here we have ADAS lane detection. So you can just click on that. So if you just go to desktop, click on the folder which you have created. And then over here, we have the image. Okay, so you would see the Sparkler image over here. So this is the image that you have pasted in the Sparkler folder. Okay. Okay, so it looks like there's a doubt. Okay, sure, I'll repeat it out. So just go to the course and go to the Sparkler chapter, image data for computer vision, and then click on download. So it will give you a zip file. So over here in the zip file, you'll find an image, which is test image.jpg. So extract the Sparkler image in the Sparkler folder. Okay, so I believe now it is clear. Okay, so let's go ahead further. So here we have the test image. So so here we'll start off with Python. So to program any, to write a Python script in Jupyter, okay. So you just need to click on new, and here you could see notebook Python 3. So just click on it. So which will give you this Sparkler window. Okay, this Sparkler tab. And over here we would type in our code. So all the program which we want to type in, we will type it over here. Okay. So first of all, let's change this, the file name. So in order to change the file name, okay, and one more thing over here, if you see in this Sparkler tab, you could see the file which has been created. Okay. So when you click on new Python 3, it will create this Sparkler file. I'll show it to you once more. I'll just close this and I'll just show it to you once more. New Python 3. So that will create another new file. So wait for a few seconds. And you can see the new file that is created. Okay. So that represents the file, like the Python script which we will be using over here. So first, we could change our Python, like the file name. So here is the file name. So I'll just show it to you once more. Just click on this. This is the file name. You can just type in maybe a file name as Python basics. Okay, so there's the file name. So you can just click on this and change the file name. So let's start off with basics of Python. So that is like defining a variable. Okay, so I'll just type it out. A is equal to 4. So this is how we could define a variable. So that is, if you want to define a variable, that is variable A is equal to 5. Okay, so which means that a variable name A contains a value of 5. I'll just run this. So you'll be able to look at the output. So you can see here, this is the variable and this is the value. If you just click on run, so that defines the variable. Okay, so this is how we could also define a variable in Python. Similarly, if you just tap on enter and type in, let's say b is equal to 10. So again, now b becomes the variable and 10 becomes the value that is stored in the variable. So you can think of b as a container. So b is the container name and 10 is the amount of, like the 10 is the value that is being stored inside the container. So now if you see, if you just click on this, like you have typed in the code, right? So if you want to run this, you can just click on run. Okay, so if you just click on run, so that will execute this particular 2 lines of code that you see over here. Okay, so which means that you have defined the variables. Okay, so the A and B value. So if you want to check out if you have defined the variables correctly or not, you can just type in A in the next section, next cell. We call this as cells. So here you can just type in A and again click on run. So this should show you an output of 3. So this is this should show you an output of 5. So this is our output. So just check out in your system if you are able to get this particular output. And just type in yes if you're able to get the output. Okay, good. So now similarly, if you want to perform, let's say multiplication or addition, you could do it like this. So let's say A plus B. So this is addition. So you can just type in A plus B and click on run. It'll give you the value of A plus B. Similarly, if you want A minus B, you can just type in A minus B and again click on run. So that will give you A minus B. Or you could also try in multiplication, division and all. So I'll just type in A star B. So that gives you the output. So if you want to store this A star B in another variable, so you can just type in C is equal to A star B. So now if you click on if you click on run, so that would store A star B value. So that is A into B is, so 5 into 10 is 50. So 50 would be stored in a variable C. Okay. So now if you want to see the C variable, you can type in C and run it. Okay. Instead of that, you could also use another command, which is print. So print, print, P-R-I-N-T, and then open up a bracket and type in C. So C is the variable and print statement would show you the output of this particular variable. So it won't give you an output of C, it will give you the C value, the value that is present inside the variable C. So I'll just run this so you can see the output. So A star B 50, which is stored in C, is shown over here as an output. So that is by using the print command. Okay. So I believe it's clear until now. You're able to see the 50 output. Okay, so that's basics of like how we could perform, I'll say, like define a simple variable and calculates multiplication, division and all. Okay. So similarly, let's also look at how we could define a matrix. So I'll just define a comment. Okay, I'll just type it out. So comment is a piece of line that we define while programming, which is defined in order to understand the program. Okay, so this does not affect your program's output, but this is just there for you to understand the program. So let's say if I run this per cell, and one more thing, okay, so I mean, like if you run this per cell, it won't give you any output, but the cell, I mean, like the text is present. Okay, so if you want to define a comment, you can just type in hash, so this per symbol, and just type in the text that you want. So you can just type in any text. Okay, so that will not affect your program's output. So let's say if you just type in matrix multiplication, okay, and run it. So nothing would happen. So there won't be any change. Okay. So like this, you can just define any kind of a comment. So now let's look at how we could use Python for matrix multiplication and all. So I'll just import. Okay, I mean, like how we could use it for matrix multiplication. So for matrix multiplication, we would need to define a matrix, and then after we would need to multiply the matrix. So first, let's look at how we could define the matrix. So by defining, it's basically specifying the values of the matrix. Okay, so I'll just define. Okay, so let's say I'll just define matrix. Okay. So to define a matrix, we would require a library. So a library or a package, we would say it as. So package is like predefined piece of code which we could use it for our application. Okay, so in simple terms, it's basically a predefined code which we could use it for, let's say, for applications which we require. So the package which I'm going to use is NumPy. So to import NumPy, you could just type in import NumPy as NP. Okay, so NumPy is the package, and to use it, I'm just importing as NP. So here you can just type in NP, and I'll just type in array. So array is used to define the matrix that we want. Okay, so I mean, like array is like basically a range of values which we're going to define, and then you could open up a bracket. So then to define the matrix, so it's like this. I'll just type it out. So let's say, for an example, the matrix is 1, 2, 3, and 4. Okay. So to define the matrix, we just need to type in the first row value and the second row value. Okay. So that way we will be able to define the matrix. So I'll just type in the values. So first row value, if you want to type it out, we need to use a square bracket. So between the square brackets, we would need to define the values. So let's define 1, 2. So we need to use comma to specify that we're going to define the next value. Okay. So then use a comma over here and tap on enter. Again, same for the second row, you just need to type in 3, 4. Okay. So that defines the entire matrix. So these two brackets to represent the array or the matrix, and this two brackets to represent the first row, and this is the first row's values. And comma, we would use it to say that we're going to use the, like define the second row. Okay. So let's run it. Okay, so it looks like I have made an error in terms of defining it out. Okay, so let's check it out. Yeah, so I need to use another bracket over here, square bracket. So let's rerun it over here. I mean, like first a normal bracket, then a square bracket. So then between that, we define the values. So let's rerun it. So that completes one per matrix. Similarly, I'll just copy this out and define this as, let's say, matrix 1. And then after, you can just change the values. Let's say you can just define any values. So there's no issues. So let's say 5. So that defines the matrix. And if you want again perform matrix multiplication and all, you can just type in matrix 1 star matrix 2. Sorry, MAT star MAT1. So that completes the matrix multiplication. Okay. Similarly, if you want to perform matrix addition, just change this to matrix 1 plus, sorry, MAT plus MAT1. Okay. So yeah, so that is like few of the basics. So I believe until now it's clear. if you have any doubts with respect to this, you can just type it out. If not, we'll go ahead further in terms of the session. Okay, so just type in yes if it is clear until now. Okay, looks good. So let's go ahead further. So yeah, so I'll start with the computer vision part of it. Few say basics, so such as like understanding what is the image and all. And so let's look at a few like basic overview of computer vision. So what is computer vision? So computer vision is, in simple terms, is like using image data to understand what output that you could get from an image data. Okay, so let's say we have an image, some kind of image. So from the image, we would need to understand few things. Let's say maybe understand where there is a link, or maybe understand where there's a vehicle from the image. So this is what we would deal in terms of computer vision. Or from the image data, okay, or video data. So we would like video or image data, we would understand the location of the vehicle. So these are like few of the applications. So computer vision deals with understanding the image data to give a output that is required. So in terms of the location of the vehicle, in terms of understanding the location of the vehicles that are present in the vehicle, so like present in the images, or understanding where there's a traffic sign, understanding that, okay, so there's a traffic sign and the vehicle should not, for an example, there is a stop sign. So the vehicle should stop the vehicle. So like the vehicle should understand the stop sign and stop the vehicle. So this is like few of the applications. So similarly, in terms of lane detection, we will be focusing in terms like understanding where there's a lane. So the vehicle should follow that particular lane. So all this are like few basics of basic applications of computer vision. Okay, so in terms of computer vision, we would need to understand first an image. So an image is basically okay, so it's basically I'll say array of values. Okay, so for an example, if you look at a grayscale image, it would give you a better understanding. So let's say we have an image like this. Okay, so which is of some particular image size. So for example, with respect to this, so let's say it's around, okay, so I'll just count it out: 3, 9, 6, 9, and that's around like 12 size. So you might have seen an image like image quality, right? Like let's say 12 into 12, 20, sorry, you might have seen like 720 into 1080p, something like that. So that represents the image size. Okay. So now if you see with respect to this, so this is around like 12 pixels. Okay. So we would say it as pixels, 12, and this would be around, I'll just count it out. Yeah, it's a 12 around, yeah, it's approximately around like, it comes around to around 18 approximately. Okay, so 18 number of pixels size. So the image size is around 12 cross 18. Okay, so this is the size of the image. I mean, like the image, I'll say pixels which are present. So 12 in terms of the width, okay, and height is around 18. So if you look at an image which has like, I mean, like if you take an image of 4K, so that would be approximately around a width of 4,000, okay, approximately 4,000 pixels width. And in terms of the height, it would be, let's say, approximately around 2,000 pixels. Okay, so this is what 4K represents. Similarly, there is a number of okay, so there is a number of different, I'll say, image qualities. Okay, so more the number of pixels, more the better. I mean, like better the quality. So for an example, if you look at this, this is around 12 and 18. So because of which it is not so clear to understand. So for example, if you have more number of pixels, let's say 100 cross 200. So then this quality of the image would be better. Okay. So what does this pixel signify? So pixels defines the quality of the image. Okay. And an image contains a number of pixels. So with respect to this, it is 12, 18. Okay. So think of it as a matrix. Okay, I'll just write it down. Matrix. So wherein 12 is like 12, I'll say individual locations of values, and 18 is individual location of the values. Okay. So in terms of matrix, we will write it over here, right? 12 cross 18 matrix. The same thing. So here we have like 12 columns and 18 rows. And each location, we have a value. Okay. So each location has some particular value. So what does this particular value signify? So this value signifies the image which we have. So for an example, here if it is represented 0, 0 represents white. Okay. This I'm talking it with respect to grayscale. So keep that in mind. I'm talking with respect to a black and white image. Okay. And if it is 255, it represents black. Okay. So that is what this, I'll say the values represents. 255 represents black and white would be represented by 0. So, okay, just give me a second. So that is what the image values represents. Yeah, just a second. There's a connectivity issue. Okay. Yeah, I'm sorry. Over here, I've written in the reverse way. My mistake. 0 would represent white. Okay. And yeah, I'm sorry. Yeah, so 0 would represent white and 255 would represent black. Yeah, I'm sorry. Looks like. Yeah, I'm sorry. Yeah, I'm sorry. I've represent again in the reverse way. My mistake. It's correct. Like, sorry. So you can see over here. I'll remove it out and write it down once more. I'll write it down directly on the image, so it'll be much more easier to understand. So here you can see it's approximately 255 would represent white. Okay, and if it is black, completely black. Okay, so that would represent 0. So 0 represents black and white is represented by 255. Okay, so this is in terms of grayscale. I mean like a black and white image. So similarly, I'll just write it down over here. Let's erase this out. Similarly, if you look at, let's say grayscale, so gray color. So that would be 0, grayscale, right? So 255 divided by 2. So that would be approximately around 125 approx. Okay, 125, 127, I guess, right, to be precise. 127 would represent grayscale. Grayscale. So that is what like grayscale, also grays represents. The gray is represented by 127. Okay. So now an image contains not only 0 and 255, it also contains gray, which is 127, and between this. So for example, if you look at this, so this particular portion probably would be 0. Okay, and this particular portion would be 255. And this one would be approximately around, let's say 127. And this one is like lesser than that. So I mean like the black content is higher. So this might be around, let's say 157 or 158, something like that. So this image contains all these values. And for each and every location, we would have these values. So you can see over here the values that is shown, and you can see the final output that is over here. Okay, so I believe you are able to understand the concept until now, so which represents the image. Okay, so now if you want, like if we have more number of I mean like high-end pixels, right? Pixels if it is higher, I mean like the image quality if it is higher, right? So then you would have more the values. So let's say now it is 12, so it'll be more than that. Let's say if you have 2000, so between this and this, there'll be around 2000 values. Okay, and similarly, if this is, let's say, between this and this is around 3000, so we would have 3000 values between these two. I mean, like with respect to the height. Okay, you would have 2000 values. So by which your image quality would be higher. Okay, and we'll be able to see a better output. So that's with respect to the basics of, basics of an image. So this image technology is used by many companies. Okay, so you can see like few of the basic few of the companies such as shown over here, like Toyota or Google, and also it's used by let's say Nvidia and many other companies. Like you could see like few of the companies which have listed down. Okay, so I'll just close this. Okay, so until now, like I believe you're able to understand what is image, like, and where like few of the applications where image is used. You can just type it on chat box if it is clear until now, because like we will be using image in terms of the entire Berkeley course. Okay, so yeah, so it looks like it is clear. So similarly, I mean, like now I have explained with respect to a grayscale image. So next we'll look at how we, with respect to a colored image. So let's open up the presentation. That's all present. So you can see here, there's a grayscale, and you can see that this is what we see, but this is what actually the image is. Okay, I mean, like what computer sees. Okay, so you can see the values and all. So computer sees this, not this. I mean, like it won't be able to understand this, but it will be able to understand numbers. So you can see what the numbers are all, all the numbers over here. Okay. And this particular example, if you see, this is 32 cross 16, the size. Then you can see like the pixel values and the row values and all. So this is the location, and this is the values, pixel values. This is the values, and there's the location. So similarly for each and every location. Okay. So next, let's look at a colored image. So for colored image, you need to understand RGB. The RGB represents red, green, and blue. So RGB is known as a color space. So we would say it as RGB color space. So red, green, blue color space. I'll write it down. RGB color space. So there is many other color spaces. So we'll be focusing on RGB color space. So wherein R represents red, G represents green, and B represents blue. So by using these three colors, we will be these three colors, we'll be able to obtain all the different colors that we require. Okay, by using the combination of all these three colors. So for example, let's say if you want only red, so we would use only red values. Okay, I mean, like basically, if you look at if you look at a grayscale, right, it is 0 and 255. So 255 would represent white, and 0 would represent black. So in the similar way, so if you want completely red, so we would say 255 for red. Okay, so that is completely red. So red would be complete. I mean, like full red, we would say it as 255. And if you don't want red, So we would say 0. So which means that no red. If you want complete red, 255. Similarly, the same applies for green and yes, I'll write it down. The same applies for green, 255 for complete green, and 0 means no green. And for blue, also the same. Yeah, 255 and 0. So for an example, we have an okay. So for an example, we have an image. Okay. So the image is completely red. So what would be the color output is? So if that would be 255, and green would be 0, and blue would be 0. Okay. So this is like RGB. Okay, I'll use another color. This is RGB. So R is 255, G is 0, and B is 0. So that represents the RGB one. So similarly, in terms of yellow, I'll use another color. In terms of yellow, so 255 for red, we would say it as 0. And sorry, in terms of not yellow, let's say in terms of green, 255 for green and 0 for blue. So similarly for blue, we would say we would just convert the 0 to 255 and remaining else would be 0. Okay, so that's with respect to RGB, like red if you want green, if you want blue. So then we also have like other colors. So that is yellow, green, blue, light blue, dark blue, or brown, black, and all. So first we'll look at black, and then we'll look at white, and then we'll look at gray. Okay. So in terms of black, so all the three colors, which is red, green, and blue, we would consider it to be 0. So you can see here this Berkeley example. So which means that it is black. So in the similar way, if you want to white color, so then the red, green, and blue. So all these three would be represent a maximum. Okay. So red, green, and blue. So that would represent white. So similarly, if you want to represent black, so it is half of it. So 255 divided by 2, which is 128, 128, 128. So that represents gray. So in the same way, if you look at another example, let's say pink, so that is red of 255. Yeah, so green of 105, 180. So like this, a number of permutations and combinations would give you different color outputs. Okay, so you can see the color colors representation over here. Okay, so that's with respect to the colors space. So then if you look at an image, a colored image, so which has a number of combinations of colors. So let's say if you look at this Berkeley image, so here we have green, okay, here we have red, and here we have yellow, white. This is white, and here we have yellow, and then here we have white again, and this is another color. Yeah, I guess like it's maroon. Okay, so I'm not sure the exact color, but let's say like maroon color. Okay, and maroon mixed with blue. Okay, so some particular color. So like this, we have a number of colors. So in terms of computer point of view, how does it see? So it will see these three individual outputs. I was saying like red, green, and blue, right? So like in terms of grayscale, I was saying there's a matrix. So in a colored image, we would have three matrices like this. Okay. So each and individual matrix would represent each and individual color values. So first matrix for red, second for green, the third for blue, and so on and so. I mean, and the same thing like would be would be present. So here the matrix size depends upon your image size. If it is a 4K, so then the number of values would be different. If it is a 2K or 1K, so that would change your number of values that are present in the image. Okay, so that's with respect to we'll say image in terms of color, like colored image. Okay, So here you could see an example. So at this particular pixel point, so this is the matrix. Okay, so only 3 by 3 values are represented. So based on that, you could see these are the individual values which are present. So the first one would represent blue. This is green, and yeah, so green, and then we have red. So by this way, like the computer will be able to, we'll say, see the individual color space. Okay, so I'll just close this and let's go ahead further. Okay, so you could see here like one of the example, like with respect to different pixel size, how does it affect the let's say image quality that we get. So this is like low pixel size. Okay, so to be more precise, this is known as pixels per square inch. Okay, so the exact term. So pixels per square inch. So that is like for 1 inch, how many pixels are present? So that is for 1 inch of size. So there is 10 pixels. Okay. So 1, 2, 3, 4, 5, 6, 10. Similarly, this is 20 pixels per square inch. And this is 100 pixels. So you can see now, like higher the number of pixels, better the image quality. But if you have higher pixels, so the the array size or the matrix size increases. Okay. So for example, this particular first one is 10 cross 10. So 10 cross 10 values. That's around 100 values. So this is 20 cross 20. Okay. Similarly, here it's around 100 cross 100. So those are the total number of values that are present. Okay. So I believe you're able to get the overall picture on how pixels is going to affect your image quality. Okay. So next, let's go ahead further in terms of like what we have studied. We'll look at how we could use it in our programming point of view. Okay. So I'll just close this, and here we'll create a new program. You can just type in Python 3. So for computer vision, there is a library. We would say it as package. Okay. So package is a predefined code which we could use it for our application. So let's say if you want to perform, let's say if you want to use it for computer vision. So we have a library which is known as, so we have a package which is known as OpenCV. Okay. So over here, like before we could use the package, we would need to install the package. So to install the package, just open up Anaconda Navigator, open up environments. Okay. Probably in your system, you would not see all this. So don't need to worry about it. You would see only this. Okay. So here, just click on, you can see this run, right? So click on that, click on open terminal. Okay. So here we could type in certain code in order to install Python. Sorry, in order to install OpenCV. Okay. So to install OpenCV, it is pretty simple. I'll just show you on how we could get the code, so which we could use it to install OpenCV. So you can just type in pip install OpenCV. Okay. So pip is one particular, I'll say, way of installation. So for installing any kind of a package in Python, we could use directly pip. Okay. And you can see here the code. So this is the code which is used to install OpenCV. So you can see like some of the manual and all, you can go through it later. But in order to install OpenCV, just copy this and paste it over here and tap on enter. So that would start installing OpenCV. So I have already installed OpenCV. So in your system, try to install it out. So once you're done with it, just type in yes. Okay. Okay, good. So yeah, so if you have installed it, you can retype the code, which would give you this kind of a, like similar kind of output. Okay, something similar would be shown. I'll just close this. So then could you just open this up? And here I'll just rename the file as computer vision basics. Okay, So now let's go ahead and discuss about computer vision part of view. Okay, sure, I'll repeat it out once more. So just go to Google and just type in pip install OpenCV. Okay, so that would give you the first link, OpenCV-Python. So just click on that. So which would give you this particular command. So copy this, go to Anaconda. So yeah, so it does, you can see in home, right? So just go to, like you would probably be in the home screen. So just go to environments. Okay, select base root and click on run. Like click on this play button. So here you'll be able to see open terminal. Click on it. It would open up this particular terminal, paste the code and tap on enter. So that will take some amount of time, like few seconds. So it will install the OpenCV library. So next, let's go ahead in terms of writing the code. So first of all, in terms of computer vision, like when we have an image, we need to import the image. So the image is already present here, the one which we have downloaded, test image. So I'll just click on this so that we could just look at the image that we have imported. Like that we have downloaded. Okay, so you can see the image over here. I'll just zoom out a bit. So this is the image. So this is one particular image of a self-driving car, which is with respect to the image, sorry, the camera which is present in the roof of the vehicle. So the image has been taken. So you can see here the roof. Like the top of the vehicle. So the camera is present. So the primary camera has taken an image. So by using this, let's perform some processing and all. Okay, I'll just close this and open up computer vision basics. Okay, yeah, so I've just zoomed out a bit. I'll just zoom in again. So here you could see the code. So like here you could see the let's say command line. So here let's type in our code. So I'll just type in import CV2. So CV2 is the library. So we have installed OpenCV, right? So in order to use OpenCV, we just need to type in import import CV2. So then after run this, so you can see the output. So like it won't show you any kind of output. So if it shows you any kind of error, so probably you have not installed OpenCV. Okay. So yeah, so if you have installed correctly and if you run this cell, it should not give you any kind of error. Okay. So that completes importing the library which we require. Okay. Yeah, so the image is in JPG format. You don't need to change the format of the image. So you can just download it directly and unzip the file. And the image, you could just save it in the same format. Like extract it in the same format. So now we have imported the library, which is CV2, import CV2. So next, after we need to import the image. So the image is present over here. So we need to import this image into Python. So for this, let's type in a comment importing the image. Okay, so that like importing the image. So here we'll just type in the code. Image is equal to CV2 the library CV2 dot imread. Imread is a command which is used to read the image. So within the brackets, we need to represent the file name. So you can use a double quotes or a single quotes, okay, because we're going to represent the file name. And this is the file name. So I recommend you to copy the file name rather than typing it out. That is because like you need to type in the exact file name, okay? Because for example, if you just type in test image and you forget to represent underscore, so then it won't be able to give you the output. So similarly, if you represent, let's say capital T, it might not give you the output. Okay. So that's why just type in CV2 imread, CV2 dot imread. Okay. Dot is required. And then between the brackets, represent a single quote and the file name. So just run this. Okay. So I believe you have run the code. So when you run it, it won't show you any kind of error if it has successfully imported the image. Okay. So just type in yes if you're able to import the image. So I believe by now you are able to import the image. So just type in yes if it is done. And if you see any kind of error, just type it out in the chat box, the error that you have obtained. Okay. So next, let's go ahead and view the image in our code. Okay. So in order to see the image here, I mean, like if you want to see the image over here, so we could use another library, which is known as matplotlib. So I'll just type in the code over here. So you can just type in import matplotlib.pyplot as PLT. Okay. So matplotlib is one particular package which is used in order for plotting any output. For example, you want to see an image as an output, or if you want to plot a graph, so let's say a 2D graph or a 3D graph. Okay. So for that, we use a package which is known as matplotlib. So you can just run this. So which would import the matplotlib, I mean like the package. So then after, to view the image, you can just type in PLT. So PLT, I mean like instead of using instead of typing matplotlib.pyplot each and every time, you can directly type in PLT. Okay. So it's basically we are going to use the short form. Okay. So then after, you could just type in PLT.imshow. So imshow is used to view an image. Okay. So PLT is the library, imshow is the command. And then after, you could just type in the file or the image which you want to view. So image is the the file name. The variable name. So you can just copy this and paste it over here and rerun it. So now you can see the output. So just type in yes if you're able to see the output in your system, not in my system. Like if you're able to see the image in your system. Okay. So yeah, that's good. So now let's further understand this image that we have imported. So this particular variable itself. So I'll just paste this and I'll run this. So now you can see the output. So this is our array of values. So as we were previously discussing, so we were saying like image would be represented by a number of values, right? So you can see all the values over here. So this is the matrix. Okay. So I believe you're able to understand. So 255 would represent, let's say, white color. Okay, you can see the background. Here, this is white, right? At this particular point. The same way, here you can see all the values are 255, 255, 255. So which means that it is completely white. So if you just scroll down a bit, so to the last value, okay, so that would represent this particular point. So somewhere at the bottom right. Okay, so that represents the entire image. So I'll just check out the matrix size. Okay, you can just type in shape. And now you can see the matrix size. Okay, so basically in terms of matrix size, it's the image quality. So you can see here, this is the height. Sorry, I'll just write it down. This is the height. And this is the width. And this is the channels. Like we were saying, like RGB channels, right? RGB. So that is what 3 represents. So the number of channels. So R, G, and B. Okay. So that represents RGB data. So red, green, and blue image data. So then after, with respect to image, we could also look at further with respect to an image also. So I mean, like in terms of image processing and stuff. So we'll look into that in the further part of it. So let's take in a quick break. So let's say 10 minutes, 10 to 15 minutes. So now it's around 6 o'clock. So we'll meet back at 6 10, 610. Okay. So in the meanwhile, if you have any doubts, type it down in the chat box. Okay. Okay, guys. So if you are in YouTube, also you can just type it out in the live chat box, YouTube live chat. So I'll type it out there itself. If not, I'll reply back to you. So for me, saying PLT is not defined. Okay. Yeah. So Bharat, just do one thing. Just type in the code over here. Okay, and run this. So you might have not run this particular cell. So that's why it's showing you that particular error. So if you run this and rerun this again, so then only it will be able to give you the output. Okay, so image data type object cannot be converted to a float. Okay. Could you just type in like where are you getting this particular code? Like when you're running this particular command, do one thing, just copy this and paste it in another cell and rerun this. So just check out then if you're able to, then you're getting an error or before that. Okay. Bharat, like just do one thing, just copy this and just run only image and just check out if you're able to get this kind of output. So probably like when you're trying to import it, you might have not got the output. So just run this image in one particular cell. Just type in image and run this. Just check out if you're able to get this kind of output. I get that. Just check, just type in image in one particular cell and just run this. So just check out if you're getting the same output. So if you're getting the same output, just type in yes. So if you're not getting the same output, you're probably getting empty. Okay, probably you're getting, I guess, like this. Okay, so without any values. So it means that there's an error in terms of importing the image. Okay, so probably you have represented the file name incorrectly. Just check it out once. Just copy the file name. Okay, yeah, so you're getting no values, right? So just copy the file name and paste it over here. So probably the error might have occurred because the file name that you have represented might be wrong, or the file might not be present here. So just check out if the file is present in the location where the program is present and you have represented the program, sorry, the file name correctly. Okay, guys, in the meanwhile, if you have any doubts, type it down in the chat box. So yeah. So do we get any certificate attending this lecture? Yeah, I'm not sure about the certificate point of view. We'll discuss this about, like in terms of the certificate at the end of the session. Okay. Okay. Then the next one is like, do we do some changes in terms of the image? Yeah. Yes. Like, okay. Like we'll be performing certain also operations in terms of the image. So that's where like image processing comes into picture. So based on which we'll be able to look at few of the outputs. Okay. Okay. So now if you see like we have we'll say looked at an image. Okay. So in terms of plotting it out, importing it out. So next we'll look at a few basic image operations. Okay. So that is image rotation, translation, and also so just image translation, rotation, and resizing the image. So in simple terms, we know that rotation. So what is rotation? So let's say we have a line like this. So we have a line. Sorry, I'll just write down. We have a line. So which is, let's say, perpendicular. Sorry, which is exactly perpendicular. Sorry, which is exactly like this. Okay, zero degrees of inclination. Okay. So now this line we could rotate it by certain angle. Let's say 10 degrees of rotation. So by 10 degrees of rotation, we'll be able to rotate this perpendicular line. So now in terms of mathematically, how could we define this out? And how we could rotate this perpendicular line by using mathematics. So if you see this perpendicular image, it will give you a better understanding. Yeah, so you can see this perpendicular image. So this is the, let's say, triangle. Okay, so there's the triangle. And this entire triangle is of theta angle. So from this perpendicular point, I want to rotate it out. So if you look at from this perpendicular point and rotate this, okay, so to this perpendicular point, so that is 90 degrees of rotation. Okay, yeah, I'm sorry, 90 degrees from this perpendicular point to this perpendicular point. So 90 degrees of rotation, right? So based on this, we could represent this in terms of a matrix. So that is what this perpendicular output is all about. So that is like, in terms of matrix, it's like this. In simple terms, I'll just explain to you. So the matrix would be helpful in order to calculate the position of these particular points. So let's say this is point 1, x0 and y0. Okay, and this is x1. Yeah, I'll erase this out. This is x1 and this is y1. So from this particular point to this particular point, with respect to this, like 90 degrees of rotation, right? So the values, the point which is at here, it is rotated by 90 degrees. So we need to know the location of this particular point. So where is this particular point after 90 degrees of rotation? So that's somewhere over here. So what is this location value? So what is the x and what is the y value? So to know this, we have a rotation. So the rotation matrix will be able to mathematically, we'll say, specify, mathematically calculate the x and y values. Okay. So that is based upon the theta values, like the theta angle of the angle of rotation, which is 90 degrees. We'll be able to identify x and y, x1 and y, sorry, x dash and y dash, whatever the naming is. So I'll just name it out over here. So x and y dash, x dash. Okay, so that's with respect to a point. So similarly, in terms of, I'll say, in terms of a image. So image is a number of values. So you can think of each and every value. And for each and every value, if you just multiply with a matrix like this, a rotation matrix, so that will rotate your image and give you the output. Okay, so that's with respect to image rotation. Similarly, if you want to perform image translation, so this is the matrix that we will be using. So Tx and ty represents the amount of translation. And with respect to a point, if you see, so let's say a point is present at this particular location. So x and y, x and y, x and y. So from this particular point, I want to go, move this particular point to this particular point. So mathematically, how could you move it? Let's say this is 0, this is 0. So if you want to move from this particular point to this particular point, so we could just say x, which is this particular value, plus the amount of translation with respect to x. So let's say 10. So then y plus, let's say 8. So that would give you O dash point, right? O dash, X dash, and Y dash values. So this 10 and 8 represents the amount of translation in terms of X and Y. So that is what the TX and TY represents. So TX and TY represents the amount of translation. So you can see here TX and TY. So the same way, in terms of a, we'll say image, we would just add it with respect to we would basically add with respect to the entire image. So then after we'll be able to translate that. So that's how we perform image translation. Okay. So I believe we are able to understand the concept. So let's go ahead further. So yeah, in the meanwhile, if you have any doubts, type it on the chat box. So first of all, let's look at how we could perform image rotation. So I'll just type in over here, rotation. Let's tap on enter. So for the rotation, first of all, we would require the image. I'll just copy this particular code and tap on enter. I'm just like re-importing the input image. Okay, image. So then after this, so to rotate our image, we need to, if you look at a point also, like for example, this is a point, and this is the point at which I'm rotating. So let's say from this particular point, I rotate to this particular point. Okay, I'll use the same color. From this particular point, it is rotated by 90 degrees. Okay. So with respect to this particular point. So this particular point represents the axis of rotation. Okay. So with respect to this, so the point is rotated from this particular point to this particular point. So we first need to specify the axis of rotation. So with respect to this particular fixed point, the point is going to rotate. So we need to specify the location of this particular point. So in terms of an image, let's say if you rotate it with respect to the center point. So then what happens? It will rotate in this particular direction, or like this particular direction, or in the reverse way, like however we rotate the image. Okay. So for this, we need to specify this axis of rotation point and the angle of rotation. Okay. And the matrix. So let's go ahead and specify those out. So I'll just type in over here height and width is equal to. So I'll first store the height and the width. So image.shape would give you the height and the width. So in this, you can just type in colon 2. So I'll just show you like what is the output that you would get. So you can see now, this is the height, this is the width. So these values, I'm just storing it in individual variable. Okay. So then after, we need to calculate the center of rotation. So center of rotation, I'll just type in as center. That is this midpoint. So now we have this this particular height and the width. So to identify the center is basically the height divided by 2 and the width divided by 2. So which will give you the center point. So I'll just copy this and open up a bracket, copy the width, just type in divided by 2 and copy height, type in divided by 2. So that will give you the center point of rotation. Okay, so then tap on enter. So I'll just rerun this. So if you want to see the center point, you can just copy and paste this. So you can see the values over here. So that's the center point of rotation. So then to rotate your image, we first need to calculate our rotation matrix. I mean, like we need to create the rotation matrix. So I was seeing, as I was shown you previously, cos theta, sin theta, one matrix, right? So we need to calculate that out. So for this, we already have CV2, OpenCV2. So we don't need to like we'll say mathematically calculate it out. So we could directly use OpenCV2. So let's go ahead and type it out the code over here. Rotation matrix. Rotation matrix is equal to CV2 dot get rotation matrix. So keep this in mind that R is capital, M is capital. Okay. So, and then type in 2D, 2 dimension. Okay. So you need to type in the exact same code, because if you type in only the exact same code, you'll be able to understand. So here we will need to type in center. So center represents the center point of rotation. I mean, like the point at which rotation has, like the fixed point about which rotation occurs. So then the angle of rotation. So how many degrees do you want to rotate? So I'll just specify for now 45 degrees. And then if you just type in scale is equal to 1. Okay, so scale is basically like if you want to enlarge or decrease the image size. So you can just specify it as 1. So which would not change the image scale. Okay. So this would give you the rotation matrix. I'll just run this. You can just select this and click on run. If not, you can just click on your keyboard shift enter. So that will give you the output. Okay. I'll run this. And you can see the rotation matrix that is shown over here. Okay. So that is what like rotation matrix output is. So that, I mean, like that we have got. So I'll just delete this. And then after, let's, I mean, like we have the rotation matrix. So then we need to multiply this rotation matrix with the image, right? So for this, we again have OpenCV. So the command here is, first I'll just type in rotated matrix, sorry, rotated image is equal to CV2 dot warp and affine, warp affine. And the input is the image. So this is our image, the source image, the first image. Okay. And then our matrix about which rotation has to occur. Rotation matrix. You can just copy paste the variable name and the size of the image. D size, the image size is equal to, yeah, I mean, like, you just represent this D size. I'll explain it to you later. So width plus 0, just type in plus 0, height plus 0. Okay. So then run this. So that will also give you this rotative matrix. So something like this. So don't worry about the values. Anyways, we'll say plot it out. So then you'll be able to get a better understanding. Okay. So let's go ahead and plot it out. For this, I'll just copy the per clip command. Let's paste it. Copy this one. Rerun this per clip code. So now you can see the output. So this is how we could rotate it out. And if you just change this, right? For an example, I'll just change this. So you get a better understanding. So that will basically translate your image by certain values. Okay, so you got it right. So I'll just change this to 0. So there won't be any small amount of translation which has occurred. So until now, I believe it is clear. If not, just type it on chat box. Okay, I know like it takes some amount of time for you to type it out, but if you're able to understand the code, just type in yes. So anyways, like the session is being recorded, like you could go through the session once more. I mean, like it's being recorded, so you can just go through it once more and type in the code. But on an overall picture, I believe you are able to understand the concept on how I'll say the program is working. So what is bar prefix? Okay. So in simple terms, it basically takes in the image, okay, and the matrix and multiplies it out and gives it the output. Okay. So that's what the sparkler function does. So the image matrix is multiplied with the rotation matrix. I mean, like not only rotation matrix, any matrix that you provide as an input. So next, let's look at in terms of translation. I'll just type in a comment, translation. Let's tap on enter. So here I'll just type in the same code. So over here, I'll just copy this, paste it over here. So which would give it the height and the width. So then we could define our amount of translation, Tx and Ty. So Tx and Ty is, I mean, like whichever values that you require, you can just define it out. I'll just copy this particular code. Let's say for an example, I'll just divide it by 2. Okay, so half the width and the height. Okay, so that's our matrix that we have defined. Okay, so yeah, so that defines our I'll say the X and Y translation. So how much translation that is required. So similarly, we need to define the translation matrix, like previously how we have defined the rotation matrix. So we need to define the translation matrix. So as it's a simple matrix, so we'll directly go ahead and define the matrix, np.array, and here we could define the values. So let's type it out, 1, 0, tx. So the one which we have previously seen in the presentation. So then 0, 1, and ty. So I'll just type in run. Okay, np is not defined. So in order to use numpy, we need to import it out. So I'll just import it out. So let's type in import numpy as np. So if you get this, just type in this particular code and rerun it. Okay, so that defines the matrix. So then also we need to define the type of the matrix. Yeah. So in terms of type, it's basic. In simple terms, it's for example, if you want to represent a integer, and if you want to represent a decimal number, right, or maybe I'll say other types of I'll say types, so such as like a string and all. So in programming, we have something known as type. Okay, so this is one of the type. So float 32 is used to represent a number, a decimal number, to be more precise. A decimal number is being represented. Okay, so that this would be considered as a decimal number. One would be considered as a decimal number. So then after, the same command which we have used previously, but over here I'll just change this to 0. I mean, like I'll just remove this, and the input is the image, but here the input is translation matrix. Okay. So then after, to view the image, the same command, but over here we'll just type in translation. So now if you rerun it, okay, so it's giving me an error over here. The variable is not defined, so I've typed the code incorrectly. So now I can see the translation. So I've moved the image by 50%. I mean, like half of it. So if you want to move it by, let's say, 0.5 and rerun it with respect to, okay, it's a 0.5, not like, let's say, I'll just decrease it by 5. So you can see the output. So depending upon what translation values that you specify in terms of X and Y, so the image would move with respect to that. So yeah, so that is what happens in terms of translation. And the final one, so it's basically a 2-line code. So I'll quickly type it out. So that is with respect to resizing. Resizing the image. So that is like, if you see with respect to an image, right? So that is with respect to this, it's 0 to I'll say 255, 2600 approx, and 3100 is the image size. So if you want to decrease this image size, So let's say 1000 and 1000. Okay. So for this, we use image resizing. I'll just type in over here. Resize is equal to CV2 dot resize. And the input is the image and the values. Okay. And the amount of resizing that we want. So in terms of X and Y. So half means like 2600 is approximate, right? So half of it, which is 1400. So this is fx, so that's the width. So similarly with respect to y, we just need to type in 0.5, like how much are resizing values that we require. And resizing is the command. So this is the input and this is the location. Okay, so this is basically the location about which the resizing has to occur. So with respect to 0 and 0, 0.0. I mean, like with respect to this particular the start point. Okay, so I'll just plot it out. So you'll be able to see the output. Here, let's rerun it. Okay, so I believe you're able to see the output. Okay, so there's, I mean, you can't see any difference, but you can see the values, right? If you observe the values, you'll be able to see the amount of change that has occurred. So here it is around 2500. So now the values has decreased to around 1250, okay, approximately. So there is around 1600. So it is half of the previous image that we have represented. So if you just change this to, let's say 0.1, so 10%. So only 10% of your X would be present. Okay, so like this, based upon the values, your image resizing is going to be. So just type in yes if you're able to, like if you're able to understand the entire concept. Okay. So this, like in the similar manner, so there is, I'll say algorithms which we write. Okay. So like how I've done resizing or translation and let's say rotation and all. So there are like few more advanced methods which we use. Okay. So not only resizing, there is something known as lane, I'll say, yeah. So there is something known as edge detection, and there is other methods such as like polynomial line detection, image calibration, and various other stuff. Okay. So in lane detection, we use, I'll say, a number of image processing techniques. Okay. And based upon image processing techniques and all, we'll be able to understand the environment. Okay. So, I mean, like not us, but basically the computer will be able to understand the environment that is present. So I'll look at, let's look at a first one of the simplest lane detection algorithm. So based on which we'll be able to understand the lane. Okay. So first thing in terms of lane detection or any kind of a Python programming, I'll say language. So first of all, we would import the required libraries. So if you see like the same way like previously how we have done. So we have imported CV2. Okay. So which is the OpenCV library. And then we have imported matplotlib. So that is the library which is used to, I'll say, view our output, and NumPy to define our matrix. And OS is one more package. So this particular package we're using to import the data. So for example, we have a folder, and inside the folder, there is a number of images. So all the images we want to import it at a single go. Okay. So then we would use this kind of a package. Okay. So first thing, once we have imported the package, is to import the image. So here I'm importing the image. So the image is in terms of a, I'll say, RGB color space. I'll say, I mean, in terms of a colored image. Okay. So the red, green, and blue data. And this is the location, and this is the file name. Okay. So there's the image. So once that is done, I'm converting this particular image to a black and white image. Okay. A grayscale image. So all this, whichever is present, it is converted to a grayscale. Okay. So I'm not showing you the code, but basically after the code is run, you'll get this kind of output. So that is like in simple terms, I'll just compare these two images so you get a better understanding. So if it is completely white, wherever it is white, so in terms of grayscale, so that would be 255, right? 255 is what we would get as an output. And if it is completely dark, let's say 0, 0, 0, RGB is 0, 0, 0. Okay, so that would be represented by 0 in terms of grayscale. So like this, we would convert it to a grayscale. So once that is done, we are doing something known as blurring. So in blurring, it's basically like this. I'll just show you a different image, so which will give you a better understanding. Let's say, yeah, so that is just a second. I'll just open up a image. Sorry, not this. Yeah, so it's over here. So you can see this sparkly image. So the one that is at the left is the actual image in grayscale. So this we would use some kind of a blurring, so wherein the image is blurred out. Okay, I mean it's not so smooth like how this sparkly image is present. Like you can see the difference, right? So image is blurred out. Okay, so once the image is blurred out, you'll be able to see this kind of output. So I mean, with respect to these two images, you can't see much of a difference. But like the next step, we would basically blur the image. So then this blurred image, we would use it. Okay, we will use another technique which is known as edge detection. So that is shown over here. So in edge detection, it's like this. Like for example, if you're drawing an image, what do? We first draw the edges. So for example, if you want to draw a car, you would draw the edges of the car. So then after we would color it out, right? So in the reverse way, so from the sparkler grayscale image, we try to identify the edges of the images. I mean, like edges of the car, edges of the lanes, and all this. So you can see over here all the lines which have been detected. Okay, so it's basically a sketch of this sparkler image. So once the edges have been detected, so in terms of lane detection, our major focus is only looking at the lane, like only focusing at this particular lane region, right? So I mean, like that's what we do in lane detection. Like we only focus at this particular section of the image. So we don't need to worry about if there's a car, if there's a building and all. So the region of interest, what it does is it just crops out the other portion of the image. So we want only this particular portion. Only this particular portion would be present, and other portions of it we just convert to a black color. Okay, so only this particular portion we would use it. So that is only portion of the lane. So the region of interest just cuts out other regions of the image. Okay. Yeah. So ROI, we basically define the values. Okay, so manually we define the values based upon your image. Okay, there's also advanced method wherein like automatically we could be able to select it. But in simple terms, we would define the region of interest, certain parameters. Okay. So then from this region of interest, we detect the lanes. Okay. So for example, in simple terms, if you see, we have the image, we have the lines. So if you connect all these lines, like let's say if you connect this straight line, it represents the image. So I mean, like it represents a lane. So a line which is, let's say, approximately perpendicular, okay, would represent the line. So which is horizontal, we'll not consider that. We'll basically neglect it out. So all the lines which are, we'll say, which is almost like perpendicular by certain angle, let's say perpendicular approximately. So that would represent the lane. So those lines which are in this particular fashion, we would connect all that. So that one would represent the lane. So you can see over here the red color So those are the lanes which have been detected. Okay. So I believe you're able to understand the concept. So if not, just type it on the chat box, like if you have not understood any particular concept. Okay. So the same lanes I've just plotted in the image. So you can see here the red lines. So that represents the image. I mean, like the image with the lane, which has been detected. So like this, the same thing would run for a number of images. So you can see how the algorithm is running. So we have just like running for each and every image. Let's say if you have 1,000 images. So for 1,000 images, we would run it and we would detect for each and every image. So this is like one of the, like simplest algorithm for lane detection. So if you have understood this particular one, just type in yes. If not, if you have any doubt, just type it on the chat box. If it is clear, type in yes, and then we'll look at one of the advanced algorithms. Okay. What's the use of rotation? So for example, let's say I have an image. Okay. I mean, like, just as an example, it does not. So for example, I have an image. It depends upon your image that you get. Okay. So it's not like for all images, rotation would be required. So for example, we have an image like this. So the image is taken from a side view. So let's say from this perpendicular view. Okay. So from this perpendicular view, we want to get the, detect the lanes. So what we could do is we could take the image. Okay. So which would probably give you this image, not like this, from this perpendicular point of view. So it will give you something like this. So something like this. So this we would need to rotate it such that it is horizontal, right? So in those kinds of examples, we could use rotation. I mean, it depends upon your application point of view. But as a simple term, that's how rotation could be used. I believe that clears your doubt. Okay. So next, with respect to the advanced lane detection, so there are more number of challenges in terms of an image. Okay. So for example, there is image distortion. So if you look at this example image, so let's say if you have a perfect image, if you take an image, so this is what you will get as an output. Same way, if you take another image, so the image will not be exactly like this. So there'll be some amount of distortion. That is like probably, let's say, if you look at this, so at the center, it's basically pulled out. Okay. I mean, like at the borders, it's basically pulled out. Okay. At the center, it is compressed. So like this, distortion would be present. Okay. So this example is a radial distortion. Okay. So there are other types of distortion. So let's not worry about that. So, but in terms, okay, just give me a second. Just give me a minute. Okay, so there's other types of distortion. Let's not worry about it. So in terms of image, so there will be a distortion. So we need to rectify this distortion. So that is what camera calibration does. So what it does is basically it takes in the image and removes the distortion and it will give you the output. So first, if you see here, like similarly like how we have seen previously, we have imported the image, like the libraries, the packages. So then after we're importing the image, so then we are, I'll say, I'm sorry. So then after we are performed camera calibration. So wherein we're removing the distortion which is present in the image. Okay, sorry. Yeah, so from the image, we would basically remove the distortion. So with respect to this particular image, if you see the first image is a normal image. I mean, like the image that is taken by the camera. And this is the second image wherein the image has been undistorted. I mean, like we'll say, uh, I mean, like the distortion has been removed. Okay. So based on this, okay, so we'll be able to better understand we'll say the image. So for example, if there's a distortion, so this lane which is present, right, it has to be perfectly straight. I mean, like if there is no distortion, it has to be perfectly straight. But if there's a distortion, right, so the lane might be in this particular manner. Okay, so we need to remove this remove this and get a perfect lane so that we get a much more better output. So first thing is we would undistort the image. So we would basically remove the distortion which is present. Okay, and we get a perfect image that we want. So once that is done, we perform perspective transform. That is, for example, if you see here, so the image has been taken with respect to the driver. Okay, so the driver is seeing the road, and based on that, the image is taken. The same image, we could use it to look at the image in terms of a top view. So for example, let's say we have an eagle, and the eagle is looking at the ground from the top. So how does it have what does it see? It would see basically the lanes as a straight lanes, like straight lines like this, right? So perspective transform will be able to help us to convert this to be viewed from a top view. So if you see here, this particular portion that is present is converted such that it is viewed from a top view perspective. Okay, only this particular portion. So from this particular portion, we use lane detection, I would say like techniques. Like we convert it to a grayscale. Okay, it's the first thing like grayscale. So you can see here. So this is the black and white image. So grayscale conversion. So once that is done, we use something known as thresholding. So this is a image processing technique. Okay, so wherein, for example, we have an image like this. Okay, so in the image we have white shades and black shades of image. So let's say this is white. Okay, and this is black shade. This is white, right? So in the white image, so let's say, it won't be perfectly like a rectangular square, the image, the white section. So there might be some amount of, let's say, gray color. Okay. So, like white and black would be mixing. So let's say there's a gray color in this particular portion. So it's not so clear. So what we do in thresholding is, we will basically specify certain limit such that if it is within the limit, we would consider that to be completely white. So even if it is gray, which is 128, we would convert this to white, 255. Okay. So by that way, we'll be able to better enhance our image. So we'll be able to get a better quality of the output that a better quality of the black and white image. Okay. So the white portion, whichever is present, would be enhanced. So we'll be able to get a bold, like a better bold image. Okay. So that's what respect to thresholding. So by specifying a limit, and based upon the limit, identifying, representing the black sections and the white sections in a much more better manner. So once that is done, we detect the lanes. So for this detection of the lanes, we use another method. So here we use something known as polynomial line. So for example, if you look at a line, so a line could be represented by y is equal to ax plus b, right? A simple line. Okay. So the same way, here in terms of a polynomial line, we use a number of I mean, like not this kind of a say equation. We use another much more complex equation. Okay, so based upon the equation, we try to fit a line. Okay, so let's say we have this pixels or this particular white section. So wherever there's a white section, we try to draw a line. So for example, there's a white curvature like this. So something like this. So by using polynomial fit, we fit a line like this. Okay, so such that it touches all the white sections. Okay, so that would give us this line that is shown over here. So if you see here the green color portion, right? So that represents the line. So that is the line that has been, we'll say, detected with respect to the image. Okay, so that line represents the lanes which are present. So from these lines which have been detected, we'll be able to identify the amount of, I'll say, curvature and stuff. So for example, if it is a perfectly straight line, okay, it means that the vehicle has to move straight forward in simple terms. So if it is, let's say, curvature is present, so what is the angle of rotation that the vehicle has to take? So depending upon your curvature of the lanes, the vehicle would need to take a turn, right? So for example, with respect to curvature, it is, let's say, we need to take 30 degrees of rotation. Okay, steering wheel, 30 degrees of rotation is required. So this 30 degrees could be calculated by fitting these lines. Okay, so that's what the next output would be. So vehicles position also and the amount of curvature. So once that is done, we'll be plotting the lanes on the image. So you can see the final output over here, which this is like the lane area. So if suppose like the vehicle is, we'll say, on the lane, okay, so it could be detected by the computer vision. So if suppose like the vehicle is moving away from the lane, so that would be identified by the advanced, I mean, like the algorithm, by defining this green region. Okay, so this is like the advanced, I'll say, lane detection algorithm. Okay, so I believe you are able to understand the concept. If you have any doubts until now, type it down in the chat box. Okay, so it looks like there are few doubts. Is there in white lanes on the road? How it will be detected? Okay, that's a very good question. Yeah, so in terms of, if suppose there is another color, so there is no issues, because here what we're doing is we're not using the colored image. So we're converted to a grayscale. So that is black and white. So if even if it is yellow color, so that would be converted to white. So because of which, I'll say, your white regions would be present. I mean, sorry, the yellow color would be converted to white. So because of which there's no issues in terms of like whichever color is present. So I mean, like with respect to computer vision, what is sliding window technique? Okay, yeah, okay, I'll explain it to you. So let's look at this Berkeley image. Okay, so we have an image like this. Okay. Yeah, okay, let's use this one first. So we have an image like this. Okay, so we have an image like this. So from this image, I was saying that we need to fit a polynomial line. So in sliding window technique, what we do is we would use a number of windows. Let's say I'll take in three windows like this. So these three windows, I will use it in order to detect the line. So three windows, you could think of it like this. For example, let's say I'll just think of as a single window. So let's say y is equal to ax plus b, the line equation. So now, in terms of this, we need to identify, let's say we have x, okay? So we need to identify y. So for this, we would require a and b. So a and b, you can think of it as two windows. So which are unknown, okay? So these two windows are unknown. So by using sliding window technique, so these two windows, I would try to fit in this particular image. So let's say for an example, wherever there is maximum white section, okay, from the bottom, I'll fit one particular window. Okay, I'll write it down over here. Okay, and wherever the also another, like the white section ends, I'll fit another window. So by using this, the A and B value I'll calculate out. So then by using the A and B value, I'll again calculate Y. So by this way, I'll like once I know the X and Y value, I'll be able to draw the line. So I believe that clears your doubts. But in terms of polynomial line, we won't only use two windows. We'll use a number of windows to get a much more better output. Okay, guys. So any other doubts? You can just type it out. Okay. In terms of a mud, so there are a number of challenges. Okay. So that is like in terms of mud, there is challenges in terms of the debris which is present on the road. And also in terms of using only computer vision, it is quite difficult because like in terms of computer vision, it has to be like much more clear like this. So if you use mud and it would be challenging to understand that there is mud and we would basically not be able to understand how. So in computer vision and all, what we could do is we could remove the mud in the image. So by using such as like machine learning techniques and all, we'll only segregate that there is a lane. Okay. So let's say we have an image like this. So from the image, we'll only remove the portions of the mud which is present. Okay. And we'll only look at the lanes. So from the lane, again, we could detect the, let's say, I mean like the lines and all. Okay. Yeah, I mean like it's a much more advanced technique. So which would require, let's say, image processing. So to remove the mud and all which is present on the road. What if it is raining? Okay. Yeah. So in terms of raining also, like, yeah. So I was saying like in terms of blood, right? So I mean, sorry, the water droplets which are present. So that's again would require a much more advanced algorithm. So wherein, for an example, in terms of raining, right? So the challenges would be in terms of like the lighting which is present. So there we might need to include sharpening of the image, and also maybe in terms of using a different color space. So the like now I've used RGB, right? So there's also another color space which is known as HSV and HSL and sorry, HSV color space. So by using HSV color space also we could tackle lighting conditions. So in the similar way, in terms of raining, we would use machine learning algorithms. So wherein we detect only the portions of the lanes. Okay. Yeah. So if lanes are not present, like we won't basically use lane algorithm itself. Like if you don't have a lane, so there's no point in using lane algorithm. So there we use something known as localization. Okay. It's more in terms of like if you look at Google Maps, right? So Google Maps specifies where you are present. The same way we use localization techniques. So that is known as visual odometry. Okay. So by using that kind of a techniques, we'll be able to detect the location of the vehicle. And then based upon the location, the vehicle will be able to drive about. Okay. Was the perspective shift important? Yes, I mean like perspective shift is important because to get a better output. So for example, if you see with respect to this particular image, so there's a number of other values which is not required. Okay, so for example, this is not required, right? This is not required. This is also not required. And also this is not required. So by using perspective transform, we can only get the portion of the image that we require. So only this particular portion. Okay. And one more thing, in terms of using perspective transform, it will basically only this particular portion would be shown, right? All this black regions which are not required would be removed from the image itself. So because of which the algorithm will be able to focus only on these particular portions of the in these particular regions which is required. So it has like lesser amount of data to be processed. So only this particular lane and this particular lane. So if there's more amount of data, it's again like time consumption, right? So which is not required. Okay, cool. Looks like you have understood that particular concept. Okay, guys, so any other doubts? Or if you have not answered any particular question, please type it out once more so that I could answer it now. Okay, so how do we deploy it in embedded system? Okay, let's say Raspberry Pi camera. So in terms of Raspberry Pi, or let's say if you use any computing device, let's say, I mean like microcontroller to be simple. So what we do is we would use a microcontroller and we would connect the microcontroller to our camera. Okay. So I'll draw a block diagram which gives you a better understanding. So here we have the microcontroller. Okay. And here we have a camera. So the camera sees the environment. So from the camera, we take the data of the image. Okay. So the image data will be given to a microcontroller. So in the microcontroller, we have this program which we have typed in. So the microcontroller takes an image. So the microcontroller performs all the, let's say, required calculations, processing and stuff. So then after, it will be able to detect the values. So for example, if you look at the values, it will be able to detect the curvature and various other values which we require. So for example, the position of the vehicle, the amount of rotation that is required and stuff. So once that is detected, so we get an output. So the output is, let's say, the amount of rotation, steering angle which is required, steering angle, and maybe let's say throttle position, like throttle amount which is required now. So these values would be again given to our vehicle. So in terms of vehicle, I mean like the like steering data would be given to our steering section, steering. I mean like the steering wheel. I mean basically in terms of like the steering wheel would be controlled. Okay, like by certain angle which we require, like 30 degrees or 0 degrees, whatever is required. So then the throttle position value will be given to our throttle. So this throttle value, whatever we get as an input, would be given to our throttle, based on which the vehicle would be able to move. Okay, what if some ahead of us cuts lane? Okay. Okay, I'll explain it out in better manner so I get a better understanding. So what you mean to say is we have a lane, okay, and some other vehicle moves like this and cuts the lane. So then what happens is like the computer, like the vehicle will not be able to see the lane, right? If I'm not wrong, this is what you're trying to say. Type it in the chat box if I'm right on what you're trying to say is, I mean, like if I've understood what you're trying to say. Okay. So now if you see, probably if you see with respect to the image that you get, you would probably get an output like this. In simple terms, you would not see any let's say lanes in the image. So probably when you take an image, you would see the vehicle here. I mean, like another vehicle's rear. That's basically this particular section is what you would see, right? In simple terms, this is what you would probably see when there's a vehicle exactly in front of you. That is somewhere over here, right? So in terms of vehicle, let's say like self-driving vehicles or ADAS and all, like we don't only use lane detection. There is also other algorithms, like many other algorithms. Like I was saying, localization and all, right? So localization also comes into picture. So wherein lane detection would be helpful for the vehicle, but it's not like only using lane detection the vehicle would run. So it also uses localization techniques and stuff. So in simple terms, like looking at the Google Maps and moving about in the environment. Okay. When I am explaining in very simple terms, but it uses a much more, we'll say, advanced techniques, which I was saying, like localization now. Okay. Okay, guys. So I believe all your doubts are clear. If not, type it down in the chat box. Hello, Suraj, you there? There's one particular question, Suraj. Like, how do we get the certificate?
Hey, Bharat.
Hey, Suraj.
By the way, amazing session, and thanks a lot for bringing quite a lot of insights and also hands-on things.
Yeah,
and
thank you, Suraj.
Quite not surprised as always to see many students staying back till the end of the session. I believe it is for learning and not for the certificates. So yeah. By the way, fantastic interaction, everyone, and very happy to see all of you till the end of the session. I believe you are enjoying the session. So, and the step to receive the certificate is just that we will send out an email to you within 2 days. Like tomorrow is being a holiday, you could expect before Tuesday. All right, so it would have a recorded lecture link, and it will also have the details of your 10 marks quiz, and then it will also have a feedback form. So you could just basically complete all of that, and then the certificate will be automatically generated. So that's the way how you can generate your certificates. By the way, any other questions from anyone else? Any other queries from anybody else? Okay. By the way, were we able to complete all the topics, Bharat?
Yes, sir. Like we are able to complete all the topics.
Okay, fantastic. By the way, when do we have a quiz? All right. So Bharat, as I was mentioning you, the quiz will be there within the the learning management system software itself. Okay. Like the same way you got an access to the course now, right? So to attend this lecture, like in the same way, our team will add you the other course. All right. So in that course, we will have the quiz. That quiz can be expected to happen definitely before Tuesday. All right. So that's where you can actually get the quiz. So do we have this kind of live classes often? Absolutely, we would be doing it, quite often from, at least like a once in 2 weeks is what we are planning to have. We will definitely like to conduct such kind of sessions in the future too. So by the way, if you guys have enjoyed the session, just give us a feedback on how was the session. So it would give us the fundamental idea that if you have enjoyed the classes, and it will also give us an idea that how should we continue ahead in the future, to conduct such similar sessions that they can benefit you. Great. So it looks like most of the people are happy with attending this session. Fantastic. All right, guys. So anything that you guys would like to give a feedback, so we are always here to hear from you. Okay, so should we get a minimum marks in the quiz? We appreciate you if you score above 60. Okay, so great then. Guys, thanks a lot everybody again for making it a wonderful session, Bharat, and fantastic interactions from everybody. By the way, very valid question, and quite interactively been putting it across your discussion, and that's what makes these sessions always fantastic and great. So we do have courses that I can that I can just give it across to you. Maybe I can just run you through some of the courses that we have on our platform. If you're interested, you can just pop into lms.decibels. Then you could just go to this course. That is, we have one master course that is on autonomous vehicle algorithm engineering, which is about 8 months with the placement support and a placement guarantee. So we also have another program that is a micro specialization, the micro specialization for computer vision. So we will send out a discount coupon for you guys. We are running an offer for the Republic Day. A mail can come to you if you're interested to enroll for this course. So it basically covers everything from the scratch. If you just have no background of Python, or if you have no background of computer vision, it's completely fine. So you will be able to gain and build the complete projects, and what you have built in a much more deeper way by writing every sort of line of code, and that's the way you will be able to get a deeper exposure. And it all starts from fundamental, and then it goes to project level, and you can execute the projects. We also have another course which is coming up. We're going to be adding that too. It will be an advanced computer vision with machine learning and other stuff that would involve more complex project scenarios and stuff like that. So that's the two things which is available with us right now. So you could just if you are interested, you could just type us on the form, the feedback form. We will definitely send out the details to you that how we can join. And addition to that, we will also have a hardware oriented program where we can suggest you to buy certain components like Jetson Nano and specific cameras and all these stuff, and you can basically implement all these algorithms into the hardware directly. And we are actually in the progress of completing that course too. So it would involve you to really implement the algorithms, and then just do it as exactly people does it in industry. Just for that, we will also give you many test cases, maybe like guys for having fantastic doubts in a way that to ask, how do we do it if there's a rain? How do we do it if there's a afternoon, if there is a evening, if it is a night? What if it is snowing? And many such kind of scenarios will be actually given as a real-time test cases to you. And this is the data that we're going to collect on the road, that we will take our vehicle, collect the data, and give it that test cases to you, so that you can basically work on those test cases, and we will support you if you have any queries to solve those test cases. So the objective is to make one to be the expertise in computer vision with this kind of series of program. If you guys are interested, so definitely you could fill us the feedback on the form. All right. So if anybody is in there, we are always happy to help you. So if any questions from your side, so we're still there to address your queries. Right, so any questions from anybody else? All right, let me just come back to the, right, so any courses on the advanced ROS for ROS 1 and ROS at? All right, so we do have a program on ROS. You can definitely explore that. Maybe we can send out a link to you. But if you have a link on the ROS, I think there's a Davis who is interested to look forward for that. Right, so the classes here always are tailored towards the specific domain. So computer vision as such, it is completely focused towards autonomous vehicles. That's the primary function. And it is also focused towards ADAS for the functionality, such as you can implement lane change assist, you can implement overtaking assistance systems. A lot of these things does involve cameras, right? So it may be parking system, it may be park assist or completely automated parking. All of this system does involve a camera or computer vision. So you could actually implement all of this in the real-time test cases. So the objective of all this kind of courses is to bring somebody to an expertise level that they can actually do the projects, and where on these areas of maybe parking systems or driver assistance systems such as lane centering, lane departure warning, or maybe the fully autonomous vehicles and stuff like that. Great. So that's pretty much, guys, for the session. I think that's pretty much from all the queries that is put across here. I want to learn Python from scratch. Okay. Great. So, by the way, thanks a lot, Bharat, for making a fantastic session, and thanks for everybody who is here, making it very much involved and interactive. Thank you again for all of you for participating in the session. So you would receive an email, and with that email, you will be able to continue ahead the process to get your certificates. Cool. And so we will definitely update you when we are hosting the next section. That is expected to be on the the next Saturday, the latest Saturday, right? So it will be possibly first week of February. We may be hosting the session. So we will definitely receive an email, and you could certainly attend that session, which will be upcoming. Thank you very much again. Until that, stay safe and enjoy your evening. Thanks a lot, Bharat, again, and enjoy your evening too. Okay. Vivek, so I would try to help you out directly. I'll ask my team to get in touch with you so that you can attend it, or else I will give you all the links for you to figure out the courses on the cross. Okay, so anybody else have any questions? If not, I will end the meeting. Thank you. Okay, so by the way, thanks again, guys, everyone. We can exit from the meeting.